Hey guys, so I figured I would go through the examples 1 and 2 for unit 1.2. Okay, so 1.2 I wrote on the board. If anybody wants a refresh from class today, these are the sample example problems that we did in class today. So if you want a refresher, if you want to see them done again, I pulled this right from Pearson and I did assign this to you. So if you do want to look at it again, this is just, I pulled the math out of the problem, but the word problems are up there if you want to look at them again. So I'm just going to solve, and these were the examples, like I said, that if you missed class or if you want to go back and look again, this was pretty much the direct lesson for today, and then the Math Excel was practice for you to do, okay? So our first example was 1.2, example 1. Now it's two parts. I call it a part 1 and part 2. It just says 1 and 2 on the example that I assigned to you. And the problem was talking about a baseball player who pitched 52 fastballs out of his 80 pitches total. Okay, so I have my 52 out of 80 total. And the question was talking about why baseball uses decimals or percentages to talk about statistics, okay, instead of fractions. So we talked about the fact that, talking about 52 80ths of pitches sounds like a lot of work, okay? So what we did was we practiced converting. So I divided my numerator by my denominator, okay? So what I did math-wise today, I did 52 divided by 80 on my calculator, okay? And that gave me a decimal answer, okay? So my decimal answer for today was 0.65, okay? And the learning target for today was we talked about what types of decimals there were. So there are terminating decimals, which come to an end, and repeating decimals that have no end. And they keep repeating on and on for however long you want to write off the whiteboard, okay? So because this one ends at the 5 or the 100th spot, we know that this decimal is what's known as a terminating decimal, okay? It's terminating because it ends. I'm sorry for the glare on my screen, okay? It is terminating because it comes to an end. So 0.65 would be the statistic of the number of fastballs that this guy pitched during a baseball game out of his 80 pitches, okay? So that's the first part of our example. And then part 2 was a similar problem with, again, the number of pitches and the number of fastballs out of the total pitches. So we had 240 fastballs out of 384 total pitches, okay? So again, we just want a decimal equivalent. So we did 240. Okay, and again, you can use long division if you like to write it out by hand, but for the sake of class time, we did it on our calculator today. We did 240 divided by 384, and the decimal we got was 0.625, okay? Now, again, this is another terminating decimal, okay, because it ends at the thousandth place, all right, or at the 5. It's terminating, so it stops. It doesn't keep repeating on and on and on. Okay, so those were the first 2 examples. Now, I'm going to leave those up in case anybody needs to copy. Again, this is just a shorter version of our lesson from today. And then example 2, if you look, we go down. And again, I assigned this on Pearson. If you guys want to look for yourselves or you want to practice on Pearson, that's totally fine. Okay, so what example 2 is asking us to do is identify which is a repeating decimal or which one continues on and on and on, or which one is a terminating decimal. So they look like the ones up here where they have an end to their decimal, okay? So the first step that we needed to do to figure out whether it was repeating or terminating was to change these fractions, these improper fractions, to a decimal, okay? And so when I did that on my calculator or if I use long division, I came up with answers of 33.3. Now, I'm going to give my 3 in the 10th spot a little hat, which means that it's repeating, okay, on and on and on. A lot of you guys in my class have seen me write it as 33.333, and I might do what's called an ellipse or that dot, 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 the periods, which means it would continue on and on and on if I had enough space to do it, okay? So either of those ways of writing it are fine. And then if I did 100 divided by 5, get a nice solid answer of 20. And then my very last one, I have 100 divided by 6, which when, again, I do it on my calculator or with long division, I have 16.6 and it's going to repeat. So I'm going to add that little hat again. So it would probably look something like this on your calculator and only give you a certain number of place values. Now, I know that I've been talking fast, so I will slow down just a second because your calculator or maybe even your phone calculator might come up with something like this, 16.6667, all right? And it looks like this decimal is terminating, which means it stops. However, because your calculator and your phone only has so much space to show the number of digits up to a certain place value, it rounds that 6 up to a 7, okay? So what it really should look like is 16.6666, and it keeps going, okay? Again, with that dot, 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 it keeps going. I'll make this a little bit bigger, okay? But that 7 would just say, hey, I'm rounding up to give you a nice clean answer, but we know that it's going to keep repeating on and on forever, okay? So to quickly label our examples, they wanted to know not just the decimal equivalent to this improper fraction. It wanted to know if it was terminating, which means it ends, or if it was repeating, which means it keeps going on and on and on, okay? So if you take a look, they definitely don't look like the other, okay? So 33.33333 repeating, okay, would be a repeating decimal, okay, because that 3 is repeating over and over and over. Okay, if I did 100, and I'm sorry, I'm going to separate my problems a bit, okay? And if I have 100 divided by 5, that's 20. Now, we talked about 0 as a placeholder today in class, okay? So if I added 20.0, and I could write 0 over and over and over again, okay? But that 0 is only a placeholder. So even though it's the same, that 0 can repeat, but it doesn't make it a repeating decimal, okay? So that is a nice solid terminating decimal or ending, okay? And then my last one, kind of following the same pattern as the first, it would be repeating because it would continue to go on and on and on for however much space I had on my whiteboard, okay? Or however much I would be willing to write, okay? So that was kind of the shortened version of our 1.2 lesson examples for today. Again, if you need any extra help, feel free to come to office hours, but these problems were assigned to you on Pearson if you want to take a look. All right, thanks guys.